Okay, thank goodness. We're finally on. ZS1 SCI and the group. ZS1 Mike returning and saying hi to everybody. Sorry for the major delay, and believe it or not, the last Murphy is called Leon Corky. I forgot that the mains in my workshop, I had the amplifiers plugged into the normal ESCOM instead of my feed from the UPS in the house. So of course when ESCOM faded, everything here was running because I've already early today put everything indoors on the UPS, but the amplifier wasn't getting any UPS power. Okay, right now you've seen the trailer that I've sent earlier about the rocket business that I was fortunate enough to watch that live at the test range where I used to work for 34 years. But I've been retired for 2 years now, but sometimes they get me back on small contracts and so on. And I have before I retired helped the KwaZulu Natal University with little video transmitters for their rockets, so that they can at least have live video from the thing. So this time they asked me if I could give them a hand again, and I did, and it was great fun. Okay, it's a very special type of rocket motor. It's a hybrid rocket motor. Now, yeah, you get many different types of rocket motors. The most basic is a solid fuel rocket motor. This is a small toy rocket motor. It contains the fuel and the oxidizer mixed in one, so it doesn't need much to start, and you can't stop it once you've started it. So what they're using there is a hybrid rocket. The fuel, let me get my rocket, my demonstration one, which you have seen before. They have the fuel kernel in the back end of the rocket, which is a hard wax grain, which is hollow. Now, in my case, the solid fuel will go in there, and you just put an igniter in, and it goes. Their ones is far more complicated. It's much safer. Even with the fuel grain in it, it's 100% safe. It cannot ignite. Even if you put an igniter in there, it'll just smoke and nothing will happen. So the rest of the fuselage, they have a long tank in there with liquid nitrous oxide in there as the oxidizer. So the thing is standing like this. They ignite, obviously they fill the whole thing. It's a whole process of filling this thing, the nitrous oxide. They fill it in at the bottom of the tank, and they vent it at the top so that there's not too much of a pressure build-up. Then they relieve the pressure a bit. It's all remotely done because it's very high pressures they're working with. They vent it a bit, close it there, and then put in more until they've got the correct amount of oxidizer in the tank. And then they have nice linear servos to retract the umbilicals, and then the thing is standing there with just the igniter wires connected to the blasting box, can you say. So I've taken videos of most of the operations, not everything, because they were very busy and I didn't want to be in their way. So I've prepared this little video, which should start to run any moment now. And I must just turn down the audio so it's not too loud. They're busy checking out the launching ramp, checking all the valves and things that they are functioning correctly. This is on the launch pad, and they are with the radios talking to the blockhouse, which is also on the launch pad. It's a heavy concrete thing which is blast proof. So if anything goes wrong with a rocket, nothing, you're safe there. Still checking out all the commands. This here is a cylinder of helium. After they filled the oxidizer, they pressurize it up to about 60 bars with helium, so that when they open the solenoid valve at the combustion chamber, the stuff squirts in there at high velocity. They're busy with the final assembly of the rocket in the final assembly room. The thing comes in those wooden crates, all the bits and pieces, and they assemble it on site. There they are busy with testing the remote control for the video transmitters. You can probably hear a bit of the audio. I've turned the audio way down so there's not too much noise. But there you'll see now there's two LEDs. On top is a video transmitter, and at the bottom there's the two LEDs on now. And then they'll switch it off again. And it looks like they've got a GPS locator in there as well. Anyway, that's the testing, and that's a bit that I was involved with the integration of the video transmitters and stuff, and make sure that it's compatible to what we use at the test range, the receiving equipment. So now it's final assembly, fitting the nose cone, and then it's off to the launching ramp. So yeah, they've got lots of checks and balances and making sure that you don't forget anything, and they put Loctite on all the screws and all sorts of things like that. They have thermocouples there in the nose as well, and they're busy making the connections now to the thermocouples so that they can measure with their small telemetry system that they have in there. They can monitor temperatures and various other things. I'm not even sure what all they have in that particular one, as I was only concerned with the video. The one camera is looking down when the thing is standing vertical, the one goes down, and the other one to the side. You can see the circular aperture on the right hand side there now. Okay, right, it's on the launcher now. Unfortunately, I missed the bit where they carried it to the launching ramp because I was busy inside filming the other things there. So there they are doing the last covers and things. Come on, where's the Loctite? That's it. And do the final things there. There you can see the two blue tanks. They're upside down. That's the nitrous oxide, which is inverted so that you get the liquid out, and the helium is standing upright, which is for the final pressurization of the system. So they are still checking the valves and things, I think. I can't hear what they're doing now because it's running on the PC without speakers. But any moment now they should put the thing in the vertical mode. There we are. Now it's ready for launch at, I think it was roughly 85 degrees elevation. And they've got hard hats on, which means now they're busy with high pressure stuff. That's the nitrous oxide filling, and also the helium pressurization in the end. Then they give it a little bit of a soak period to absorb some of the environmental heat, to pressurize it a bit more as the stuff heats up, it expands. Now look at the fins at the bottom. Apart from that, they've written their names on it. You can see that the fins are mounted at a slight angle. They're not plumb onto the fuselage. There's one of the servos that will pull out the filling hose at the bottom of the rocket there in the silver part. That's where the filling hose is coupled. And there's a similar one at the top where they vent it. And just before launch they retract all of those goodies, and then the thing just stands on there on the launching rail. Here's the top one, and that's all operated from inside the blockhouse. Now this thing, if I remember correctly, it's about 5.5 meters tall, this rocket. There they are now pressurizing it, and they are measuring it. They're drawing a graph of the pressures inside the oxidizer tank. So even there, if you have oxidizer leakage, nothing will ignite because the wax is still hard and cold. There's the launch now. This is inside the blockhouse. There's Professor Michael Brooks standing on the left-hand side below the countdown. And I must turn up the volume a bit now so you can get a bit of the sound when the thing takes off. This is inside this heavy concrete building. The safety officer sitting in the middle, and the high-speed camera operator is the guy in the green shirt there. 15 seconds to go. Turn up the volume a bit.
10, 9, 8, 7, 6,
now listen carefully.
5, 4, 3, 2, 1. Launch.
Successful launch. And there's the whole crowd sitting in the blockhouse, all the engineers who worked on it. This is from one of my cameras outside. Unfortunately, there was very high winds, and it was we had to wait until late in the afternoon. There were ships in the sea. We had to wait for them and for the wind. And it was also not a perfectly clear blue sky day, which is also not ideal. But anyway, it was still a beautiful launch. The countdown should... I can't hear it now. Maybe I must just put my sound on. Oops, I can't hear it now. Maybe I must just put my sound on.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
There's the igniters on. You can see the smoke. And there it goes. Okay, that's from my one camera. I had another camera outside. So
that's from my one camera. I had another.
So just kill that. There's the other shot from the other camera. I forget the countdown again.
30, 25,
Yeah, it starts at 40, so that 30 now.
20,
Oh, 25.
15, 10, 9, 8, 7, 6, 5, 4, 3, 2,
There's igniters.
launch.
Okay, so the interesting part is they ignite it, and the igniters start to melt.
They
To-
ignite it.
Oh, come
and
on,
then
mute. Starts to melt some of the wax, so it gets a nice fumes of and there's another view of the launch from a distant camera. And only once you've got that molten wax, and you add the nitrous oxide, then it ignites. Okay, and the next morning they found it on the beach. It fell in the sea like planned, and the sea washed it and spat it out on the beach, and it's intact basically. So yeah, that is the story of the Phoenix 1D rocket. And yes, with great thanks to Professor Mike Brooks for allowing me to firstly to film it, and then also to give me the rights to broadcast it on the worldwide satellite. Thanks very much, Mike. That's highly appreciated. All right, this is one Mike. Then give it to I'll give it to Gary. He can sort out the mess that I've caused. Over to you, Gary. ZS6 Yankee India for the group.